Good evening, everyone. I'm Dr. Vivek Tiwari. I'm a joint replacement and bone tumor surgeon from Apollo Sage Hospital, Bhopal, India. Today, I'm going to talk about calculation of sample size. Now, sample size calculation is an integral part of the vast majority of quantitative studies. It is important in ensuring validity, accuracy, reliability, as well as scientific and ethical integrity of the study. There are three main parts in its calculation. First is estimation of the sample size, which depends on a host of items. Second is justification in the light of budgetary or biological considerations. And third are adjustments accounting for potential dropouts or effect of covariates. There can be various consequences of getting the sample size wrong, which can be scientific, ethical, or economical. The problems can be approached in two ways. Patients I need approach, which is based on calculation of sample size for a given power, significance, and clinically meaningful difference, or patients I can get approach, which is based on calculation of power for a given sample size and the level of significance. Now, what are pilot studies? Pilot study is a preliminary study intended to test the feasibility of a larger study, data collection method, and collect information for sample size calculations. It should not be regarded as a study which is too small to produce a definitive answer. Rather, it should be regarded as a tool in finding the answer as long as it is followed through. The sample size calculation may not be required for a pilot study. Now, what is the importance of sample size calculation? There are scientific reasons, ethical reasons, and economic reasons. The scientific reasoning is that in a trial with negative results and a sufficient sample size, the result is concrete. On the other hand, in a trial with negative result and insufficient power, that is insufficient sample size, one may mistakenly conclude that the treatment under study made no difference. The ethical reasoning is that an undersized study can expose the subjects to potentially harmful treatments without the capability to advance knowledge, whereas an oversized study has the potential to expose an unnecessarily large number of subjects to potentially harmful treatments. There are two approaches to sample size calculation. One is precision analysis, another is power analysis. Precision analysis is done in studies concerned with estimating some parameter which need precision, accuracy, and prevalence, whereas power analysis is done in studies concerned with detecting an effect. It is important to ensure that if an effect deemed to be clinically meaningful exists, then there is a high chance of it being detected. There are various factors that influence the sample size calculation. They include the objective, the details of intervention and the control treatment, the outcomes, whether it is categorical or continuous, single or multiple, primary or secondary, what is the clinical relevance of the outcome, any missed data, whether there are any covariates to control, what is the unit of randomization, whether it is individual, family practices, hospital, wards, communities or families, what are the unit of analysis, what is the research design, whether it is a simple RCT, a cluster RCT, an equivalence study, a non-randomized intervention study, an observational study, a prevalence study, a study measuring sensitivity and specificity, a paired comparison, a repeated measure study, and whether are the groups equal. And the factors related to research subjects, what is the target population, what are the inclusion and exclusion criteria, what is the baseline risk, the patient compliance rate, as well as patient dropout rate. The other factors that influence the sample size calculation include, is the follow-up long enough to be of any clinical relevance? What is the desired level of significance? What is the desired power? Whether one or two tail test is employed? Any explanation for the possible ranges of variations in outcome that is expected? What is the smallest difference? And what is the justification of previous data, whether it is published data, previous work, review of records, or an expert opinion? And lastly, what is the software or formula that is being used? We need to know the numerical value summarizing the difference of interest, that is the effect, that is whether it is odds ratio, relative risk, risk difference, difference between means, or correlation coefficient. The p-value, it is probability of obtaining an effect as extreme or more extreme than what is observed by chance. The significance level of a test, that is the cutoff point for the p-value, which is conventionally taken as 5%. The power of a test, that is the ability to correctly reject the null hypothesis when there is indeed a real difference or association. It is typically set at least 80%. And what is the effect size of clinical importance? We need to know whether we need to employ one-sided or two-sided tests of significance. The two-sided tests are used when an alternative hypothesis suggests that a difference exists in either direction. On the other hand, one-sided tests are used when it is completely inconceivable that the result could go in either direction or the only concern is in one direction. Examples are toxicity studies, safety evaluation studies, adverse drug reaction studies, and risk analysis studies. The expectation of the result is not an adequate justification for a one-sided test. So how to approach sample size calculation? First, we need to specify a hypothesis. We need to specify the significance level alpha, specify an effect size, obtain the historical values, specify a power, use the appropriate formula to calculate the sample size. After the study is finished, we need to compare the variance of the actual data with the one used in the sample size calculation. So these are the various formulas used for sample size calculation. For cross-sectional studies, for qualitative variable, for the quantitative variable, for case control studies, for qualitative variable, for the quantitative variable, for cohort studies, and for testing a hypothesis when between two groups when the endpoint is quantitative data and between the two groups when the endpoint is qualitative data. Now, there can be various reasons to when failure to achieve the required sample size is there. There can be patient refusal to consent, bad time of the study, that is, for example, heavy clinic study in the winter, adverse media publicity, weak recruiting staff, lack of genuine commitment to the project, lack of staffing in wards or units, or too many projects attempting to recruit the same subjects. So what are the possible solutions? Pilot studies can be done. We can have a plan to regularly monitor recruitment or create recruitment targets, ask for extension in time and or funding, review your staff's commitment to other ongoing trials, and regular visits to trial sites. The strategies for maximizing the power and minimizing the sample size are use common outcomes, use paired design, use continuous variables, and choose the timing of the assessments of primary outcomes to be when the difference is most likely to be optimal. We can have to recalculate the sample size in the mid of the trial when we change the input factors and when there are increasing accrual rates. Retrospective sample size calculation is very controversial and most people recommend to avoid it as it really doesn't add more information in most cases and may confuse or misguide the conclusion. Thank you for your attention.